Greetings and salutations, everybody. Beautiful day for a webinar. How are you, Peter?
Good, thank you, mate.
Oh,
Hello,
very good.
everyone.
For those who haven't met Peter before, he's our Ocean Protect's Queensland Specification Manager. Been with Ocean Protect how many years, Peter?
12 and a bit, nearly 13,
A
I
long
think.
time. We're actually one of the modern technology. We're coming to you virtually, but Peter and I are literally standing next to each other. So, but we've got noise cancelling headsets. And our Queensland manager is promised not to sing too much during our webinar presentation today. So we'll see how we go.
Fingers crossed.
Fingers crossed. We live in hope. But yeah, look, again, thanks for everyone for giving up their time today. Much appreciated. We've got about 240 registrations at last count, which makes Peter nervous. But that's just a conversation between you and me, Peter. But and just a reminder, this is what are we, number 9 of the Stormwater Fundamentals series for this year. Again, super popular series. Always so thankful and amazed by all the people that give up their time to tune in to hear about all things stormwater. And today is about the radial flow cartridge systems. But yeah, just a reminder, we've got 3 more webinars to round off the series. And if you're keen to dial into those, feel free to jump on the Ocean Protect website via the link below. And if you're wondering how come I don't get told about these things, well, you're probably not subscribing to our newsletter, and we plug the webinars in each of those newsletters, so give you an idea of what's coming up. So if you're not receiving our webinar, please jump on that website there and subscribe, issued every month with a whole bunch of news. And just a reminder, folks, before we dive into the official presentation, please put any questions in the Q&A panel. And as per always, the slides and recording from today will be made available at that website there. And you'll probably get an email probably a week or so from today with that link, etc. As well as CPD forms. So we're streamlining this as best we can. Apologies if you've been waiting for a CPD form, but I think essentially everyone's getting a CPD form automatically nowadays. So if you don't get one within a week of the webinar today, please email marketing@oceanprotect.com.au. And yeah, so today's session is about radial flow cartridge system technologies. I'll be myself and Peter presenting today. And if you're, look, this is essentially what we're going to talk about today. We're going to talk about what are they, how they work, where they're used, how they're maintained. We're going to give an overview of some performance monitoring studies, demonstrating their efficiency, talk about where they're approved for use, and also how to specify and how to model them in music if you wanted to go that far as well. And just as a precursor as well, I'm going to focus most of today's session on the typical radial flow cartridge systems used in typical stormwater applications, but I'll touch on a little bit of an innovation towards the end as well. But fundamentally, Peter, do you want to explain to the amazing attendees what they are and how they work?
Yeah, so radial treatment technology, there's a few different technologies available, but the one that we sell and have sold a lot of and specified a lot with Ocean Protect is our storm filter cartridge. The storm filter cartridge is basically a media-filled cartridge that can be housed in precast tanks below ground or in a combined detention tank system at the inlet end traditionally. Basically what happens is water flows into the tank where the cartridges are installed. There's a weir wall in the back end of the chamber that fills up. Air is purged out through a one-way air valve at the top of each of the cartridges. Once it gets to a certain height, depending on what height cartridge filter you have in the system, the float pops and water's drawn radially through the outside of the full surface area of the cartridge, through the media inside the cartridge, down through the hollow center tube, through an orifice disc that's at the base of that hollow center tube, and down through the underdrain pipework and out through the base of that overflow weir where the treated water exits the chamber. We have multiple media options available, which we'll talk about a little bit further in the slides as well, which makes the storm filter cartridge a very flexible option to be used in stormwater treatment. We can do offline internal treatment chambers, like you can see here, when you do have high flows, or you can do a traditional external offline configuration, which again, we'll probably touch on a little bit later in the preso as well.
Cool. And if you're wondering what the hell, let's show the animation, but here's some real world examples of what they look like in the field, including a very recent design, Peter, I think that top one.
Yeah, so the top one is a recent sort of update. We have started manufacturing our own precast detention tanks called Urban Pond. The middle photo there at the top is showing how we can integrate storm filter treatment cartridges into an Urban Pond detention tank, showing where the inlets are coming in and the cartridges are. It's a little bit hard to see, so forgive us for that. Then we've got some other photos there. Of bottom left is one of the precast treatment systems with storm filter cartridges to be installed within, going in the ground. And then you can see a few combined detention tank and rectangular precast vault units that we've installed historically on many, many jobs throughout Australia. As I said, that it's probably the most flexible treatment option available in regards to, you've got so many different options where you can use the storm filter cartridge, whether it's in precast tanks, combined in detention systems, in situ tanks, if you've got projects where, a conventional size system doesn't really work due to site constraints. We also have 3 different height cartridges available. Basically, the tall cartridge, 840 mil in height. The standard and the short cartridges are both 600 mil in height. However, they do have a different float. So the siphon and backwash mechanisms, which happens inside the cartridges that I touched on earlier, actuates at a different head or a different weir height. Okay, so just keep that in mind. If you've got a constrained site, we do have different height cartridges you might be able to use that we can get to work within your site constraints.
So where are they used, though, Peter?
Yeah, so historically they're used widely in commercial, industrial, and residential areas. We have used them on heavy industrial sites like airports and ports and different things like that before. But yeah, widely used on any commercial, industrial, and residential site.
Yeah, and obviously there's flexible options, so you can have like as small as 1 cart, for example. But there's some systems that are, I think the biggest one in the world is a 1,000 cart system at LAX airport. So yeah, all shapes and sizes, configurations, and yeah, lots of them. This is essentially the flagship product, sorry, from Ocean Protect. I've just done these numbers, so we've installed, Ocean Protect have installed over 41,000 cartridges in Australia alone, but it's not a technology unique to Australia. There's about 250,000 installed overseas, particularly in the US, via our partners, Contec. How are they maintained, Peter?
Yeah, so maintenance is typically done through 900 by 900 access covers. There's circular ones shown in the video here, but traditionally we use 9 by 9 access covers above where the cartridges are located. Confined space access, A-frame, guys winched up, sucker truck. We can remove the top cap of the cartridges and remove the hood. It's key for inspection of how the media is going from time to time, which is also needed, and also allows us to suck the media out of the cartridge and pass the cartridges out empty. It's one of the unique things with the storm filter cartridge and one of the advantages to its design. We can also pass the cartridges out full and empty them at the warehouse down the track. But the ability to, suck the media out of the cartridges while they're still in the chamber and pass them out empty is an advantage, particularly where you've got constrained sites with, shallow internal height tanks and different things like that. Makes them a lot lighter to maneuver and get in and out of the tanks when maintenance or exchanging of the media is required. We'll talk a little bit more about maintenance, but we reuse and refurbish the outside parts of the cartridge, replace it with new media, and they go to different projects. So think of it, for lack of a better analogy, which I'm yet to come up with after 13 years, a little bit like swap and go with your gas bottles at the service station, where we're arriving to site. We know how many cartridges are in there. If they need replacing, we'll have refurbished cartridges with new media that go into the tank, and the old ones are removed and sent back to the warehouse again to be refurbished and sent to a different project.
Mm. And to see this, here's some happy snaps as well. We've got obviously everything in terms of maintenance requirements are basically outlined in our storm filter operation and maintenance manual. But here's some sort of happy snaps as well, before and after photos. You can see the filter media is a highly absorbent material, is really good at absorbing a whole bunch of pollution, and it's literally just swapping out with new cartridges. And Peter, you talk about the components all being reused. The filter media itself, though, that's, I think, at least in Queensland, it's disposed to landfill, isn't it?
Yeah, currently, it's mainly the outside parts of the cartridge that are reused and refurbished. The media inside, when we replace it or suck it out with the sucker truck, is occluded and no longer viable for stormwater treatment. So it currently goes to landfill in Queensland. I think in New South Wales it is getting recycled. But yeah, that's basically the only part that we don't reuse. The rest of the cartridge is reused and refurbished and sent out to a different project.
Cool. And we always get asked this question. So I've included this slide in this webinar today. It's straight out of the maintenance manual. So in terms of how often we need to do maintenance. So fundamentally, maintenance does vary from, depending on the site characteristics, but we do recommend inspection every 6 months with a minor service at 12 months. So minor services be just like removing accumulated sediment in the chamber, etc. But in terms of replacing carts, it's as required, but generally we expect carts to last between 1 to 3 years.
And it really depends on the type of site, like Brad mentioned. Rightly or wrongly, there is no set rule that every site has the same pollutant load. Industrial and commercial sites will have higher pollutant loads. Residential sites traditionally will be lower. However, there is anomalies to that as well. So this is why we have a 1 to 3 year expected media life, not a blanket 3 or 2 or whatever. I seem to see, based on maintenance that we're doing on a lot of projects, which we do, the residential sites do tend to go longer towards the 3 year mark, whereas the industrial and commercials probably average around the 2 year. But 1 to 3 is what we generally say.
I'll talk to some of this. Sorry, Pat.
Yeah, when the media needs replacing within the cartridges.
I'll talk a little bit later about some of the science behind those numbers as well. But in terms of, I guess, some science, there's a lot of science to back up the performance claims of this asset. So it's not just a one-off study. There's now to date 5 real-world studies, 4 of which that are published, demonstrating the performance of these assets. There's been 2 peer review reports, in addition to a SQUID verification, which is another set of independent reviewers. We've done 1 longevity study, but fundamentally, the vast majority of councils across Australia allow them to be used on private sites, and it does have SQUID approval. Everything I've just said also, and I'll probably refer to this document a few times, but everything in terms of approvals and data and government, performance monitoring data is all available online at on our website. In that document, you can see on the right-hand side, it's called a Review of the Application of Stormwater in Australia. Basically provides a whole bunch of information around data, approvals, peer reviews, etc. But just to give you a very quick snapshot on some of these studies. So these are the 5 studies, I guess a summary of those 5 studies of the storm filter, which is obviously a radial flow cartridge system. So there's been 2 in Australia so far and 3 in the States. The top one is very recent. That was of a storm filter NP-sorb system, which is a new filter media we put in storm filters, which I'll talk to a little bit in a sec. But that's just one study of 5 that's been undertaken. And you can generally see fairly consistent performance removals for each of the studies that have been undertaken to date. And again, all that information is in that review paper on the left-hand side there. But if I just touch on 2 of the studies that have gone through the SQUID verification process. So the first one was used to demonstrate the performance of the storm filter P-sorb. And the storm filter P-sorb is basically the storm filter cartridge with what we call P-sorb media in the cartridge. So the filter media is this stuff here you can see in the overall cartridge. So we can use different filter media types in this cartridge. And in this case, a P-sorb filter media was applied. This was a site in the States, in Oregon, and this was monitored for over 2 years with 16 events collected, and those are the results. So yeah, 89%, 82 and 50 for TSS, TP, and TN load removals, and similar numbers for concentration reductions as well. This study was actually peer reviewed by Damien McCann from AWC, a consulting company, and then it went through the SQUIP process with Dr. Baden Myers from University of SA, verifying that it complied with the SQUIP requirements. So just some happy snaps from the study. So yeah, it's basically a road catchment in Oregon. You can see, I guess, the installation there, the storm filter, there's a rain gauge, etc. But yeah, operating for just over 2 years and doing a great job protecting the local waterway. But a more recent study was in Western Sydney. This was a 16-month monitoring study. 16 events were collected. There was 2 cartridges installed in the Western Sydney University car park. And again, similar performance rates. And again, this went through the peer review process via Stormwater Australia SQUIP by Damien and Chris Beatshaw from Aflux Consulting. And again, that was demonstrated to be compliant with SQUIP. Again, this is what we call storm filter and P-sorb. So it's a little bit different filter media relative to P-sorb. And operates at a higher flow rate, which I'll talk to in a sec. But yeah, this is some happy snaps from the study. It was essentially in a car park catchment. That's the catchment area. It's a little installation here. You can see that's where essentially the storm filter was installed. There's a little monitoring cabinet there as well. For people who are a fan of Filterra, there's actually the Filterra bioretention system that's been studied now for 7 years, was literally next to it. But this is the storm filter and P-sorb cartridges in an underground chamber with a whole bunch of tubes, etc., collecting samples and monitoring flows, etc. So the storm filter and P-sorb is very, very similar to the P-sorb. P-sorb has been around for a long time, and P-sorb is a newer version of P-sorb. Fundamentally very similar performance rates, but the P-sorb cartridge essentially can operate at higher flow rates. So generally speaking, because of the high flow rates and similar performances, for comparable sites, you generally need slightly less cartridges if you're applying storm filter and P-sorb relative to P-sorb.
Yeah, so the flow rate difference is roughly around about 20% between the N-P-sorb and the P-sorb filter media cartridges. The reason the flow rates are a little bit different is we use a different orifice disc at the base of the cartridges. Okay, so those orifice discs are very important because they actually set the flow rate through the media. The media itself has a much higher flow rate than that. The orifice disc is basically slowing down the water passing through the media to get those good removals and those TSS, TP, and TN reductions that you can see there. So yeah, you'll get less cartridges with an N-P-sorb filter than a standard P-sorb one. We do also have our ZPG media, which is the first media blend that we basically sold in Australia, still available as well. But moving forward, the P-sorb and N-P-sorb are widely used for the majority of projects throughout Australia.
And Peter mentions that flow restricted disc or orifice disc. So see the pink thing there, and it's yellow there. Basically, this essentially controls how much flow goes through the cartridge. Obviously, if the filter media was completely blocked up with pollution, that might be the hydraulic constraint. But generally speaking, it's this orifice disc that actually controls the flow through the cartridge itself. So yeah, the N-P-sorb has a different color disc to the P-sorb disc. So different orifice discs, different controlled flow rates. I touched briefly on this longevity analysis that have been done. So this is there's been 20 plus years of R&D has gone into storm filters where we are today. And this is one of the studies. This is a study done by Radial Solutions a few years ago. Essentially, so Radial Solutions, if you're not familiar, they're an independent consultant based on the Gold Coast. And we asked them to essentially do a study to see how our cartridges were operating over a long period of time in the real world. So they basically took storm filtered cartridges from 5 different sites they selected across the Gold Coast. All had been operating between 1.5 to 3 years with no maintenance, so no cartridges had been replaced. And they essentially did flow tests in their own facility on those 5 used systems, and also 2 new ones, to see if there'd been any deterioration in flow over that time. And fundamentally, the new and the old, or new and the used cartridges all had the same flow rate. Again, because it was the flow restricted disc or orifice disc that was actually determining the flow through it, not the pollution accumulated. So again, these are just words out of their report. So if flow rates used as an indicator, and this is generally how you determine whether a cartridge might need replacement, or at least one of the ways you can determine by doing a flow test.
There's a couple other ways. If you see it holding water for long periods of time, of course.
Yeah, and obviously if it's holding water, it's not flowing, draining properly. But Blacktown City Council, for example, give a flow test procedure that they recommend should be followed, and yeah, that's how they essentially determine whether a cartridge might need replacement or not. And yeah, that Reduced Solutions basically said if that's the methodology that you apply, storm filters shouldn't need replacement before about 3 years of operation, again, depending on the catchment characteristics. That's just one study. This is just to dive into some of the data behind the 2 Squid App verified studies I showed before. This is essentially the TSS, total phosphorus and total nitrogen removal efficiencies observed at both of those monitoring sites. First one being in Oregon, the US, for PSORB, and the other one being for NPSORB for Western Sydney. And you can see essentially there's no obvious or no significant deterioration in concentration reduction over time, even though they've obviously been in the ground for a while. So for the Oregon system, it had been in the ground for 27 months. For Western Sydney, it had been in the ground for about 16 months. So again, no decline in pollution reduction efficiency, again, providing evidence for that, the longevity claim that we essentially apply throughout Australia. Speaking of applied throughout Australia, as I touched on this before, it's pretty much approved everywhere for use across Australia, for private sites at least. So some councils do allow them to be used on public sites, but yeah, long story short, if a council allows any proprietary devices to be used, I'd almost guarantee that they certainly allow storm filters to be used.
It's very highly likely that storm filter will be on that list.
But if in doubt, obviously just check with us, and I'll touch on this a little bit later, but yeah, the modelling and design procedures can vary from council to council, so it's obviously often a good idea to just check with us anyway. In terms of key advantages, Peter, look, in terms of, for me, look, Peter's been looking at storm filters longer than I have, but there's probably a few key things that stand out for me. Number one, the performance. There's so much data that is published and unpublished. It basically demonstrates that these systems work really well. It's gone through a bunch of peer reviews and approvals, etc., and fundamentally is accepted by even the most stringent water quality regulators across Australia, Brisbane City Council, Blacktown City Council, etc. And there's so much. For me, they're almost I wouldn't say bulletproof, but certainly a very highly resilient system. You can throw a lot of nasties at this, and
very robust, very robust. Let's say that.
And even if you dropped a bomb on them, you could just replace them very easily.
They're not bomb-proof, but anyway,
not bomb-proof. But if some of them, for example, if you had a massive fuel spill, which we have seen, you just suck it out and replace the cartridges. Whereas it'd be a lot more difficult to try and rectify a vegetated asset, for example, if something like that happened. But yeah, there's 20 plus years of R&D that's gone into these systems. Like I said, they've been applied, 40,000 plus in Australia, 250,000 across the planet. So there's a lot of work that's gone into making sure that they are super resilient and perform a really good function. For me, another key thing, and I think really this is where the stormwater industry needs to go more holistically, is we provide a turnkey solution. So the Ocean Protect design and install and actually can maintain these assets as well, as opposed to just...
We don't have to maintain.
Don't have to.
We're maintaining a lot of systems these days, and we're keen to always maintain them. Doesn't have to be Ocean Protect, but we're definitely keen to provide that service for any project. I guess the other key thing too is there's a few design, I guess, things that are significant to the storm filter cartridge. So we do things a little bit differently. The ability to, Brad, can you go back to that slide with the video, possibly, mate?
Yeah,
The
back in
storm
the
filter,
day.
the first one.
Yeah.
We do have, the removable hood, the unscrewable cap on top, so you can inspect the media and suck the media out. We also have the under drain pipework encased in a false floor, so you don't have trip hazards when you're maintaining the system. A flat working surface inside the chamber for maintenance to remove captured pollution that sits around the cartridge on the floor of the system as well. We also have on the outside edge of the hood the scrubbing regulators that lets air agitate the full surface area of the outside of the cartridge, and helps basically wash anything that was on the outside of the cartridge down to the cartridge floor, meaning that it's ready for the next rain event to come and filter through the media again. So there are a few specific things in the design of the storm filter cartridge that set it apart and above most of the other cartridge or stormwater treatment devices on the market. Yeah, so it's a very robust system. It's been around for a long time, and it has some significant design advantages with the concrete false floor and the under drain pipework. You won't have standing water at the bottom of your chamber. So yeah, it's a very robust system. One of my favorites. Categorically say that since I've been working here for 13 years. Yeah.
And obviously, one of the key features is it's easy to integrate. Like you can just integrate them underground, so maintain the usability of ground surface areas. Often they're integrated in car parks, I don't know, open space areas, etc. As long as you can access it for maintenance.
Yeah, and that is the key thing to consider when you're designing where the systems go, of course, as well. Mentioned it in one of the webinars last year that we did as well. Always consider access requirements and different things like that. But we're happy to assist in that regard for any project. Just let us know what the constraints are.
Cool. How to specify, Peter?
Yeah, so basically we can do the majority of that for you if you like. As consulting engineers, if you send us some details of your project, we're more than happy to put together a music model for you relevant to whichever LGA that your project falls in. Send you back a copy of the model so you can run it, check it, look at it, do whatever you want with it, and provide any budget pricing or details, example drawings, or what we call specification drawings relevant to the systems that we've used in the music model. Alternatively, if you guys want to do the music models yourself, we can happily give you the music nodes and details on how to model it. More than happy just to check models if that suits you better. But look, basically, we're here to help. We're happy to help. There's no charge for our help. We're doing it to try and get specifications on drawings. So feel free to utilize us if you wish. But yeah, happy to be as involved or not as you like, and point you in the right direction if you right direction. If you need to do something quickly and do it without our assistance, that's fine too.
Cool. But if people want to do a music model, Peter, they can.
Yep.
So if you're familiar with music, it is a combination of a detention node and a generic treatment node. And obviously we generally recommend modeling consistent with the local requirements, and generally most councils nowadays prefer to apply the SQUIDAP methodology, the SQUIDAP verified methodology.
Certainly in Queensland, but anyway.
In Queensland, yeah, it does vary. This is the thing where it gets confusing. You've got different media types, different council requirements across Australia, recognising there's something 535 councils across Australia. They often have different rules. So if in doubt, I would be suggesting just to contact Ocean Protect just to make sure what the requirements are for that local area. And again, Ocean Protect can do the music modelling, no obligation, no cost. So probably a good border call as the first thing. I'm just thinking, I know we have a lot of council people on this call, Peter. I know there's a lot from a very local development assessment department. Is there any particular things that they should be checking for when it comes to cartridge modeling?
Yeah, there's a few things. The storm filter chamber node in particular is one that you probably want to check. There's a few specific things relevant to the tables that are on the screen there in regards to what height cartridge we've used, what flow rate per cartridge, all things like that you might want to check just to make sure that it lines up with what is being specified and what is being modeled. There's also some areas within the storm filter chamber node. When we do models, if we've got a 4 square meter chamber area with say 3 cartridges sitting inside that chamber, we will take the area of the actual cartridge, each cartridge off that area that we model within the node to make sure that we are modeling just the volume of water that basically is kept below the weir that has to go through the cartridge and be treated. Okay, so we're not over exaggerating or anything like that. We also changed the K values in that storm filter chamber node to 1, so it doesn't act as an additional treatment node. Okay, that's pretty consistent these days, but historically it had been an issue. But yeah, these days and with some of the Squid App approvals, it seems to be more consistent than it used to be. But it is something to keep an eye on.
Yeah. So key fudge factors for me that I see, not just our devices, but certainly just more general proprietary assets is, fudge factors, assuming that there's performance or pollution removed in the detention chamber when really their approval or performance data is based on the combined system applied at the generic node. So long story short, the K values, if you're familiar with music, the K values should be 1 or 0, so you're not double dipping performance. Double checking the performance, removal rates that are modeled in the generic node, making sure that they're consistent with the local approval, and also making sure that the high flow bypass is appropriately specified as well. So
treatment flow rates
Mm.
match the relevant number of cartridges or device being modeled. Yeah, and in my opinion, the area of the cartridges within those chambers should be subtracted as well.
Yeah. So if in doubt, and this goes for council authorities or DA approval staff, if you're in doubt, not sure, we're happy to check our own models or check the models of others as well. So if you need us to do a peer review, we're happy to do that as well.
Brad made a mistake once, I'm sure of
it. The rumors, one can only speculate. Oh, and one more thing. One thing around the Radial cartridge system is that, like I touched on before, you can use different filter media in these systems, and we've actually developed a filter media. You might have heard me talk about it before around removing PFAS. So if you're not familiar with PFAS, it's a hot topic, per and polyfluoroalkyl substances. It's a potential carcinogen. It's certainly very a major concern if you're a military base or an airport or a firefighting training facility, because they are considered hotspots for PFAS contamination. But PFAS is almost ubiquitous everywhere, and they're seeing in all sorts of environments because it's in our waterproof clothing, pesticides, etc. And historically, it's been a real massive issue for stormwater as well, but with no stormwater technology to remove PFAS from stormwater until we developed one. So we've basically reconfigured our storm filter cartridge to use a different filter media that has been specifically developed to remove PFAS. It's basically particularly good for military bases, airports, fire training facilities. There's actually a heap of data on this already. This is really new. If you jump on the website at the bottom of the screen, there's a whole bunch of more information around those field studies. But yeah, we've done 3 to date. There's actually going to be another 2 happening in the next few months. But fundamentally, it's really good at removing PFAS. We can also
You've
do
got a whole webinar
monitoring
coming up on this, haven't you, Brad?
No, well,
is it not the last
PFAS,
one in this series?
Yeah, the last one, keeping everyone in suspense. But we're going to touch more broadly on PFAS. But I'll touch on this technology as well. But it's really really quite new, and there's a bunch of advantages that we've seemed to have brought to this area that no one has. So we can do remote monitoring. We've got independently authored guidelines and safe work method statements. The maintenance is different because we want to just essentially keep the filter media contained within the cartridge. So we literally remove the whole cartridge, appropriately enclose it, and then take it to an appropriate facility. But the key feature that most people are interested in is the fact that it's just so much cheaper than alternatives out there. So we're generally finding we're 5 to 10 times cheaper than the next cheapest option. So getting a lot of inquiries, as one might speculate, from various motivated clients, including just councils and road authorities. So if you're keen to find out more, just jump on that website at the bottom, which includes a review paper, which talks about the real world studies, etc. But if you're keen to know more as well, obviously you're welcome to reach out to myself or Peter. So that's a crash course in radial flow cartridge systems. I hope you guys learn a few things. I'm happy to take. Peter and I are happy to take any questions. If you do have any questions you'd like to ask Peter or myself today, please put it in the Q&A. If you don't get a chance or you want to ask a question in confidence to Peter and myself, obviously our email addresses are on the screen as well. And just a reminder, folks, please put the questions in the Q&A panel. I can see a few things in the chat already, but if you do have questions, please put them in the Q&A panel so we can track them appropriately. And like I said before, we always get asked this, today's slides and recording will be made available at oceanprotect.com.au/webinars. And CPD forms, we will email you guys probably within a week, CPD forms for today. But if you haven't received it in the next little while, just reach out to us via email. Cool. I think we've wowed the masses, Peter. I'm not sure how many questions will come through. A few people have said they had to duck off earlier. That's kind. That's fine. I think we just said, oh, sorry, I nearly cancelled the webinar on everyone. I pressed the wrong button. Apologies. That could have been tragic. But look, if no one has any questions from today, we're happy to just have a chat offline. Thanks everyone for dialing in. Again, the key questions I generally get asked is the maintenance. We always get asked around what do you do with the maintenance? So what do you do with the spent filter media, and how often do you maintain that? Like I said, we generally want to put this stuff into a landfill facility, at least in Queensland. We are doing some work with some groups to look to repurpose the spent filter media into something usable, but I can't disclose too much information about that right at the moment. But yeah, we are looking to repurpose this this is probably the one thing that we'd like to sort of, I guess, close the loop on. Basically take a pollutant, a polluted filter media and repurpose into something that actually is pretty cool and snazzy. And the key question, again, we always get asked is just how often you need to replace these cartridges. It's generally every 1 to 3 years. I know on the Gold Coast, Peter, I think they actually specify has to be done every 2 years.
Yes.
But yeah, if there's no further questions, I'm happy to cut the webinar short today. Everyone gave an early mark. And just a reminder, folks, sorry, I'm dancing around. Please, just a reminder that we do have 3 more webinars in the series. Our next one is actually by Dan Rhodes, who was pegged as Dan Rhodes from Optimal Stormwater. He's now Dan Rhodes from Ocean Protect. So Dan Rhodes actually joined us. Nothing against Optimal Stormwater, great bunch of guys. But we're fortunate that Dan Rhodes has actually joined Ocean Protect as our senior water engineer in Queensland. So he's actually going to be delivering next webinar as an Ocean Protect employee, which was not envisaged, I promise. And the next one after that is Daniel Ryder on Law and Order for Maintenance of Assets. And I'm going to finish off 2025 with a webinar about PFAS, which seems to be a hotter topic every time I jump on the news.
I might add one thing before we do go, Brad. Got to give a shout out to Mr. James Lenhart, one of the key guys who worked with Stormfilter in its infancy and done a lot of development in that space. The Radial cartridge or technology wouldn't be where it is without Mr. Jim Lenhart. So shout out to Jim. Don't know if he's on, but anyway, shout out.
Yeah, so Jim is the godfather of stormwater. He is almost the reason why we're all here, isn't he? Like, so yeah, super smart guy, podcast favorite, and yeah, a legend in his own right. I do have a question from Dan Jensen. He's asked about the radial flow PFAS filter, and I think we probably need a whole webinar on this because it has some fundamental differences, particularly in relation to maintenance. Yeah, but Dan asks, to remove the PFAS, do you need to run it through a normal filter first? So, yeah, I'm not sure if you're talking about removing the PFAS after it's absorbed to the filter media or something different. But for when we're applying the radial flow PFAS filter, we actually do put the stormwater, or often I'd say actually probably 90% of the applications that we've looked at to date are actually been groundwater treatment projects. So we basically run the PFAS contaminated water, whether it's groundwater or stormwater, through some sort of pre-treatment. It's generally our jellyfish membrane cartridge system. Now the reason we do that is because organics and solids will actually compete with PFAS in terms of the absorption for being absorbed to the filter media. So if we can remove the organics and solids, we basically mean the filter media in the radial flow PFAS filter has basically more space or more absorption capacity to remove PFAS. So yeah, we run the flow through jellyfish to remove the solids and organics prior to actually running the treated flow through a PFAS filter. But
We also very
yep.
often, for more traditional sites that we're not dealing with PFAS, use our Ocean Guard pit baskets to pre-treat before the PZorb or the NPZorb media storm filter cartridges as well. So it is often a treatment train approach, and it is, it's the best way of dealing with different contaminants that we're trying to capture. It's one of the key things. I always like the word capture, not remove. It stays inside the cartridge or inside the vessel, so it does need maintenance.
But in terms of PFAS, what you'll find with jellyfish or ocean guards or pretty much anything that hasn't got something specific targeting PFAS, it won't generally do much to remove PFAS. So we've got data to support that. So with the studies we've done to date, we run it through the jellyfish, and jellyfish, like I said, good at removing solids and organics, doesn't do anything significant for PFAS. But once the water goes into the PFAS filter, yeah, obviously that's good at removing PFAS. We generally get removal rates between 80 to 90%. But that PFAS, to Peter's point, doesn't actually just magically disappear. It's retained or captured within the filter media. And then we need to physically remove that cartridge out of the, often a tank or system. And from there, it's generally would be disposed to an appropriate landfill facility. Now there's rules around how much contamination something can have while still being allowed to be placed in a landfill. I think it's generally around has to be PFAS contamination has to be less than about 50 milligrams per kilogram, but the filtered media generally is lower than that, so it's okay to put into a landfill facility. I hope that answers your question, Dan. But if you're keen to find out more, feel free to reach out to myself or Peter after today. Cool. Well, there's no further questions, everyone. We will. Oh, sorry, there are. Sorry, I've just realised there are questions. I've just seen the Q&A pop up now. So Gregory Chian, we did touch on this. How often do we have to swap out the filter media cartridges? What is the life cycle? Yeah, so again, if I just go back to, where is this? This is one of the previous slides around maintenance. So yeah, this essentially answers that question, Gregory. So we generally see that generally the media or cartridges needs to be replaced between 1 and 3 years. So on the Gold Coast, they specify has to be done every 2 years. But yeah, to Peter's point before, some residential sites are probably you probably get away with not replacing it as frequently.
Yeah.
Yeah. So, but yes, all sites are different, and some sites are just dirtier than others for some crazy reason. So yeah, I hope that answers your questions. Greg also asks, we have a few situations in the photos where there are tin cans, grass trimmings, etc., on and around the filter. Would this impact performance? If so, what recommendations do you have for drainage design to avoid such situations? Yeah, to Peter's point before, I'd say the vast majority of storm filter applications have pre-treatment upstream.
Yeah,
So
typically we use OceanGuard pit baskets in graded inlet pits for your ground and road catchment areas. Not so much the roof area. Roof areas typically are quite clean or cleaner when compared to ground and road catchment areas, and you've got less chance of obviously having grass clippings and tin cans. But yeah, we typically use the OceanGuards as a pre-treatment device before the storm filter cartridges.
Cool. Great. I hope that answers your question, Greg, but if you've got any further questions, feel free to reach out to Peter and myself. Cool, guys. So again, these are our contact details if you want to reach out to Peter and myself following today. There's more questions coming in the chat. Great, you can provide them all the stumbling blocks, CSD. Thank you, Colin. Or just, yep, thank you. I think people are just saying, yep, that answers my question. Cool. Well, again, thanks everyone for their time today. Thank you, Peter, for joining me on the webinar today.
No worries.
And
well done, everyone. Thanks for tuning in.
And we'll hopefully see you the next one. Thanks, guys. Enjoy the rest of your day. Bye for now.